Okay, what I think I'll do is work a couple examples that are similar to the homework on page 627. So I'm on page 627 in the text, and I think I'll try to work through maybe number 12 and maybe number 14. So number 12, this is page 629. Let's see if I can work number 12. That would be Joe Namath. So I have 2i plus 2j. And vector w is I plus 2j. And we're supposed to do three pieces. Number one is simply to find the dot product. Part B is to, what do we have here? Find the angle between and then third, state whether it is these vectors are parallel, orthogonal, or neither. All right. So, well, let's start down the checklist here. The first is the dot product, which is the sum of the products of the corresponding components. So this is first component times first component, second component times second component, and multiply and add. So this is 2 plus 4 is 6. So part 1, dot product, 6. B, find the angle between. Well, we know cosine theta is v dot w over the product of the magnitudes. We already have the numerator computed, so we know that's 6. It hasn't changed in the last few seconds. And then we need the product of the magnitudes. So we need the magnitude of v is 2 squared plus 2 squared times, and then we need 1 squared plus 2 squared. So we have 6 over, this is the square root of 4 plus 4. Can we say 4 plus 4 is 8? And the square root of 1 plus 4 is 5. Remember our rule, this product of the square roots is the square root of the product. That actually makes it a little more convenient to compute. And so 6 divided by the square root of 40, I'm going to simply appeal to the calculator. I have 6 divided by the square root of 40, and that works out to be 0.9486. I'm going to just say 0.9487 approximately. This is approximately that. And then we want theta is cosine inverse. This is now an approximation of 0.9487. Again, I'm going to leave the exact value in my calculator to take a cosine inverse of that result. I have cosine inverse of that answer, and I have approximately 18.4 degrees. If you have rounded in a different place than I have, then you might not have this quite, you might have 18.5, you might have 18.2. If you show me your work, I will not penalize you for rounding differently. So approximately 18.4 degrees is the angle between the two vectors. And then C, well, are they parallel, orthogonal, or neither? Well, neither. If they are parallel, then the angle between them would be either 0 or 180. If they were orthogonal, the angle would be 90. And since it is neither of those, this is neither. So these are neither of those two. So that's number 12, worked out in all of its little splendor and glory. All right? All right, number 14 we'll also work through. I'm going to leave this piece up here because the directions are the same. Just a different vector to work with. So, or pair of vectors to work with. So this is number 14, Dan Fouts. So, vector V is, we have radical 3i minus j. And W, we have I plus j. I'm sorry, this is number 14. I'm sorry, I wrote down number 13. Number 14, I'm sorry. Number 14 is I plus square root of 3j. This is now the correct problem. And then vector W is I minus j. All right, so A, V dot W, the dot product. So the corresponding components, so this is 1, 1, and square root of 3, negative 1. So this is 1 minus the square root of 3. This is approximately 1 minus 1.7. The square root of 3 is approximately 1.7. So this is approximately negative 0.7. Part B, cosine theta, is the dot product, which we know already, be negative 0.7. Then I need the product of the magnitudes, so that needs to be 1 squared plus square root of 3 squared times 1 squared plus negative 1 squared. So what do we get out of that? That's negative 0.7 over, this is 1 squared is 1, radical 3 squared is 3, so that's 1 plus 3 is, that's the square root of 4, times the square root of 1 squared is 1, 1 squared is 1, so that's the square root of 2. So this is 2 square roots of 2. So this is negative 0.7 over, we can write this as the square root of 8. And that is approximate. These are all now approximations because I've approximated this 0.7. That's going to be negative 0.7 divided by the square root of 8. And I have that to be approximately negative 0.2474. Or negative 0.247, actually it's approximately 75. But I want theta now to be cosine inverse of that 0.2475 or 2.74, however you round is fine by me. I want cosine inverse of that previous result, and that works out, I have to be 104.3. So this should be approximately 104.3 degrees. And so there's part B. And part C is very straightforward again. They're neither parallel nor orthogonal. So this is neither. In order to be parallel, the angle between them must be either 0 or 180 degrees. In order to be orthogonal, the angle between them must be 90 degrees. This is neither.